Hello guys, yet again we come, and now guys we are doing this question. I can read the question first. Given that xn is an approximation to the root of the equation x cubed plus 3x plus 2, use Newton-Raphson method to show that a better approximation is given by that. Hence, determine the root taking x0 is equals to negative 0.75 and correct to 4 decimal places. So guys, we come and now use this equation. So in using the equation, guys, we need to find the derivative of our function, which is now the derivative of that function is x cubed plus 3x plus 2, because this will come to 3x squared plus 3. And so guys, that's what we have done here. Only that guys, we have to put our n into place. We make sure that we put n because guys, this side we are supposed to be putting x in form of xn. Now xn minus, just as I said, you put a bracket there, then you put your function, which we are given x cubed plus 3x plus 2, and then you put the first derivative of that function, which is now 3xn squared plus 3, which is this. Guys, now you can make the whole equation to be 1. That is, both of these will have the same denominator. And that can happen when you multiply xn multiplied by 3xn squared n plus 3 all over, you put down there 3xn squared plus 3, so that guys, they are the same denominator. And that's what I have done here guys. So when you have put that, you can remove the bracket. Remove the bracket means that this is going to be negative and also this is going to be negative. So guys, I can now come and evaluate 3x cubed minus x cubed will give us 2x cubed n. For this one, guys, this is now going to cancel. That cancels that. Then we are now left with a negative 2, which is there. This is negative 2. All over now 3. So guys, this is now what we are proving. Just as the question had asked up there. You can see this is what we are proving. Now we've been able to prove. Then the other question is, hence determine the root, taking x0 to be that. So the first root is going to be negative 0.75. And that's what we have here guys. We use this equation. Our n plus 1, we take it as 0 plus 1, which now gives us 1. While this one, n will take it, let n be equal now to 0. So n plus 1 is going to be 1. It's going to be 1 here. While this one is going to be x0. We are told that x0, I can put here x0 is 0.75. So that's what we have put here, cubed, and this is squared. Guys, when we evaluate that, our solution we should find as 0.6065. Guys, now we come again and now we are looking for 2. Because now this one was n plus 1, this is going to be n plus 2. So this is 2, 0 plus 2, this is 2. And this one is now going to be x n 1. We shall have x subscript 1, this is x subscript 2. Using still the same equation, that is x subscript 1 here, x subscript 2 for this. When we replace that, we cubed, and this is what we are now, this is what we are seeing is x subscript 1. This is what we replace here. We cube there, we square there. When we do that, guys, we will get that as our equation. This is now x subscript 2. And we come again and now put our x subscript 2 here. This is x subscript 2. And this is x subscript 3. So when we do that, guys, we will get this answer. So looking at both of that answer, you can now see, guys, we are almost having the same answers. And because of that, guys, we would not need to go far because it means we shall get almost an answer like this. And so, guys, we now just come and put that answer into 4 decimal places. And that one will now give us this. We shall get this. We say 1 plus 1, 2, 3, 4. This one is below 5. And so, therefore, it will remain like this. So, therefore, guys, this is our solution. Thank you, guys, for listening to me. Bye-bye.